go. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. When you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. So this morning we'll be going on to cover section 9.4. But first of all, are there any questions from yesterday?
No, I don't have any.
All right, then we'll just go right on to 9.4. 9.4 has to do with multiplying and dividing radical expressions. The first thing I want to look at is an idea. I think we might have explored this idea a little bit yesterday, but either way, we'll do it again. What is the square root of 5 times the square root of 5?
2.
No, we're not adding.
Isn't it square root of 25?
Yes. Which would be
5.
5. Okay. So we could actually just go straight here.
Yeah.
What's the square root of 7 times the square root of 7?
The square root of 49.
Yes, which is
7.
But again, we could actually just go straight there.
Yeah.
What's the square root of 15 times the square root of 15? Just give me the final answer.
15.
Right. That's what I was trying to get you to do, is to skip this step, to say, oh, it's just 15, okay?
Okay.
All right. So now, let's say we have the following problem. The square root of 5 times the square root of 15, okay? It says multiply and simplify. All variables represent positive real numbers. There are no variables in this problem, but I want to look at a couple of different ways that we can deal with this problem. One of them is we could say, well, that's equal to the square root of 5 times 15, right? We could put those together. In fact, we could even say that's equal to the square root of 75. And then we could say, but that's equal to the square root of 25 times 3, and the square root of 25 is 5, so we get 5 square roots of 3. Are you okay with that?
Yes.
Okay, so that is a way, not an incorrect way, a way to do this problem. Here's another way we could do this problem. We could think of this as the square root of 5 times the square root of 5 times 3. Okay?
Okay.
Which would be the square root of 5 times the square root of 5. Whoops, hang on. Which would be the square root of 5 times the square root of 5 times the square root of 3, right?
Yes.
What's that?
Square root of 25.
No. Yes, it is, but jump to the finish line. It's
5. Sorry.
5. Yeah, I'm trying to get you to skip that step because you don't need to go there. So that's going to be 5 square roots of 3. Welcome, Gregory. Nice of you to join us on this Friday. All right. So that's 5 square roots of 3. Okay. Same answer, just a little bit different way of looking at it. All right. Let's see here. Let's even look at it one more way. This would be equal to the square root of 5 times the square root of, oh, wait, that's not what I want to do. Hang on. That would be equal to the square root of 5 times 15, or the square root of 5 times 5 times 3, which is the square root of 5 squared times 3, which is 5 square roots of 3. I'm really doing the same thing, just slightly different ways of doing it. And they're all good. It's just kind of however you want to go about it. But you see what I did there? Yeah. In each case, I'm getting those 5s together. All right. Let's take a look at another problem. -3 times the square root of 11 times the square root of 33. So this could be written as -3 times the square root of 11 times the square root of 11 times 3. Okay.
Okay.
In fact, and eventually I'll start skipping some steps. I could have gone straight there from here. Okay. In other words, I could go from here to here. You see how I did that?
Yes.
But what I really want to focus on is what's that? Careful.
11.
Good. Thank you for not saying the square root of 121. That's not wrong. It's just that just get straight to the head to the finish line. And there we have that. Okay. Let's take a look at this. 2 cube roots of 16 times negative the cube root of 4. All right. That would be equal to -2, and I'm getting that from this -1 times the 2, cube roots of 16 times 4. Do you see how I got there?
Yes.
But that would be equal to -2 cube roots of, isn't 16 4 squared?
Yes.
So this would be 4 cubed. Okay, because this is 4 squared times 4 cubed. So this is -2. What's the cube root of 4 cubed?
4.
4.
Final Jeopardy answer, -8. Thank you, Alex Trebek.
Wait, so going back to that 16 times 4, you wouldn't be able to bring out that 4 and get -8 and then, no, never mind.
I didn't hear anything. Did you hear anything? Nope, didn't hear.
Oh,
You got to you see it? Oh, no, go ahead.
can you hear me now?
I can hear you. Can't now though. Yes.
Okay, so for the 16 times 4 that you have in the, do you see that? Yeah.
Mhm.
Would you be able to bring out a 4 for that 16 or no?
Bring out a 4 for the 16.
Or would you not be able to since it's being multiplied by that 4?
Oh, okay. This is what I think you're saying. Let's just focus on that. Okay. You're wanting to bring a 4 outside,
Yeah.
but it's not a square root. It's a
Oh,
cube
that's
root.
right. That's right. Yeah. Never mind.
So all we could do this, we could write it as 8 times 2 and bring a 2 out, but then, yeah, so.
Yeah. Yeah.
All right. Okay, good. But keep exploring. How about this? Cube root of 3 times cube root of 18. This is the cube root of 3 times 18, which is 9 times 2, which is 3 times 3 times 2. Okay. So I took this and went right there, and this went right there. You see where I'm going with this?
Yes.
This is that. What's the cube root of 3? Oh, that's not 3 squared, it's 3 cubed. My bad. I need to slow down here. Just slow down. What's the cube root of 3 cubed?
3.
And then we've got the cube root of 2 left over. So we're looking at the index. We're building powers to match the index so we can kick them outside. All right. You good to go on?
Yeah.
Okay. 3 times the square root of 8x times the quantity 2 times the square root of 2x cubed y. So that would be 6 times the square root of 16x to the 4th y. Are you okay with how I got that?
Yes.
Yeah.
All right. What's the square root of 16?
4.
What's the square root of x to the 4th?
X squared.
And we've got the square root of y left over. So we've got 24x squared times the square root of y. All righty.
Yeah.
So the square root of 8 isn't nice, and the square root of 2 isn't nice, but the square root of 16, which is 8 times 2, is nice. So we're kind of taking pieces that aren't nice and trying to put them together to make them nice. It's all about nice. All right. Let's see here. The 4th root of 2r cubed times the 4th root of 8r squared. That would be the 4th root of 16r to the 4th times r. Now, again, why did I do that? 2 times 8 is 16, and 16 is 2 to the 4th power. R cubed times r squared is r to the 5th, but I went ahead and broke it up into r to the 4th times r because of the index. Okay, so kind of thinking ahead.
Yes.
All right. 16 is what? 2 times 8, 2 times 2 times 2 times 2, 2 to the 4th power. So the 4th root of 2 to the 4th times r to the 4th times r. What's the 4th root of 2 to the 4th? 2. What's, oh, sorry, what's the 4th root of r to the 4th? R. And what's left over? The 4th root of r. The nth root of a to the n equals a when a is greater than or equal to 0. That's what's behind the scenes. That's sort of the goal, is to get to that so you can take things out. Have you ever heard anybody say, I wouldn't want to be a member of a club that would have me as a member?
No.
Do you see what that's saying? Well, this club, the idea of this club is to get kicked out. This is the 4th root club. So we want to create 4th powers so they get kicked out. We're trying to match the index or multiples of it so they can get kicked out. So the goal is to get kicked out of the club. All right. Multiply and simplify. All variables represent positive real numbers. And here again, this first couple don't even have variables, but here we go. So now we're going to be distributing. Okay. So I've got 2 square roots of 7 times 3 minus 2 square roots of 7 times the square root of 7. Sorry, my 7s and 2s kind of look the same there. Okay. Now, this is 6 square roots of 7 minus 2 times, okay, what's that?
7.
Good job. Okay, so 6 square roots of 7 minus 14, or you could write negative 14 plus 6 square roots of 7. Okay, the authors did it this way, but either way works. You all right with that?
Yes.
Yeah.
Very good. Ausgezeichnet. All right, here we go. The cube root of 3 times parentheses 2 cube roots of 9 plus the cube root of 18. Okay, so we're going to distribute. We're going to get the cube root of 3 times 2 cube roots of 9 plus the cube root of 3 times the cube root of 18. Okay?
Yes.
Now, let's look at this. I've got 2 cube roots of 3 times 9, which is what? 27, which is a cube, right?
Yes.
3 cubed,
Yeah.
okay, plus the cube root of 18 times 3, which is 54, which is 2 times 27. Okay. Now, why did I break it up that way? Because 27 is a
Cube root.
it's a cube, and it's going to get kicked out here in just a minute. Okay. So 2 times the cube root of 27 is 3, so that's going to be 6. Here, the cube root of 27 is 3 cube roots of 2. So 6 plus 3 cube roots of 2. And those aren't like terms, not like radicals, can't put them together. So don't write 9 cube roots of 2, okay? Not the same flavor of ice cream. This is Rocky Road and this is vanilla or something like that, okay?
Yep.
All righty. Let's see. Again, all variables are positive. Basically, it looks like this whole section, all the variables are positive. Okay. The square root of 2 plus 1 times the square root of 2 minus 3. So now it's kind of like we're foiling two binomials together. We're going to take the square root of 2 times the square root of 2 minus 3 square roots of 2 plus 1 square root of 2 minus 3. Here, I'll go ahead and put the 1 there. I don't really need it there, but okay. Do you see where I got those? Here, let's even do this. So there's my 4 products. Any questions so far?
No.
All right. What's that?
2.
Are those like terms?
Yes.
So I'm going to have minus 2 square roots of 2 and then minus 3. So then I'm going to get what? Negative 1 minus 2 square roots of 2. Or negative 2 square roots of 2 minus 1 if you wanted to switch them around. All righty.
Yep.
Let's see here. How about let's see. The cube root of 3p minus 2 cube roots of 2 times the cube root of 3p plus the cube root of 2. Okay? Do you feel like somebody sat down and tried to figure out how nasty of a problem they could create in their spare time? Sometimes it seems that way. Okay, here we go. The cube root of 3p times the cube root of 3p plus the cube root of 3p times the cube root of 2 minus 2 cube roots of 2 times the cube root of 3p minus 2 cube roots of 2 times the cube root of 2. Good thing I can write past the whiteboard there. Okay. In fact, let's see what happens if I do this. No, that doesn't switch and change it over. Okay, we ready?
Yes.
So this would be the cube root of 9p squared. Can't do anything else with that because 9 isn't a cube, p squared isn't a cube. So we're stuck with that. Okay. Plus, that's going to be the cube root of 6p, 3p times 2. Okay.
Yep.
Minus 2 cube roots of 6p. Oh, these are going to be like terms, aren't they? And then minus 2 cube roots of 2 times 2, which is 4. So I didn't have any cubes inside, did I? So nothing came out. All I can do is combine those two middle terms. So I've got the cube root of 9p squared plus 1 minus 2 is minus 1 cube root of 6p minus 2 cube roots of 4. All righty.
Yep.
After that, here's some nice stuff. What's the square root of 11 squared? Careful.
11.
Yes. What's the cube root of 9 cubed?
9.
Now be careful. What's 2 square roots of 5 squared?
2 square roots of 5.
I've got 2 square roots of 5 squared. Let me show you what it is. That's 2 squared, the square root of 5 squared. So it would be 4 times 5 or 20. Because you're squaring that, which is going to give you 4, and you're squaring that, which is going to give you 5. You see it?
Yeah, I forgot that you have to distribute it.
Yeah, that 2 goes with the 2 and the square root of 5. All right. How about this? 9 minus the square root of 11 squared. So that would be 9 minus the square root of 11 times 9 minus the square root of 11. Okay? So now we're going to FOIL it. We're going to get 9 times 9 is 81. 9 times minus the square root of 11 is minus 9 square roots of 11. Minus the square root of 11 times 9 is minus 9 square roots of 11. And what's minus the square root of 11 times minus the square root of 11? That would be plus
11.
Good, 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 good. So now I've got what, 92 minus 18 square roots of 11. All right. Any questions?
No.
New idea. Okay. We're going to do what's called rationalize the denominator. But before we do that, let's talk about rational. Four is a rational number. The square root of 4, which is 2, is a rational number. 3 is a rational number, but the square root of 3 is not rational. You cannot write it as a fraction or a whole number or a repeating or a terminating decimal. The square root of 3, let's see, on my calculator, the square root of 3 is 1.732050808, and then it rounds off. Okay, it would be kind of like me. It just goes on and on and on, or like the Energizer Rabbit. So what we're going to do is we're going to try and take an expression that has an irrational denominator, and we're going to turn it into a rational denominator. All right, now let's say I've got the square root of 5/3. That's equal to the square root of 5 over the square root of 3. I want to rewrite this fraction such that the denominator is rational. So my question is this: what do I have to do to the denominator to turn it into a rational number. So what am I going to put right in here? The square root of 3 times what would give you a nice rational number? The square root of 3, because wouldn't that give you plain old regular 3?
Yes.
But if I'm going to multiply the denominator by the square root of 3, I must also multiply the numerator by the square root of 3. So in fact, all I'm doing is multiplying times 1. I'm just choosing my 1 in such a way that it rationalizes the denominator. Now, what's my new numerator? The square root of 15, which is not rational, but they're not asking us to do that. They just want us to rationalize the denominator. The idea being, it's sort of thought of as a simplifying process, better to deal with just a single number inside of a radical rather than a fraction. So this is a process that does that. Okay, but the key is rationalizing the denominator. Let's take a look at another example, see if you can pick up on this. So that's equal to that. What am I going to multiply the top and the bottom by?
The square root of 7.
There you go. Oops, equals. So now I've got 7 in the denominator, and I've got the square root of 56 in the numerator. However, unlike the previous problem, 56, the square root of 56, can be simplified further. Let's see, 56 is what? That's 8 times 7, 4 times 2 times 7, 4 times 14. What am I doing? I'm looking for perfect square factors. So that's going to be 4 times 14. And what's the square root of 4?
2.
So I've got 2 square roots of 14 over 7. So I've rationalized the denominator, but I also simplified the numerator as much as I could as well. Okay?
Yep.
All right. 8 over the square root of 10. Rationalize the denominator. What are you going to do?
Multiply by the square root of 10.
So then you get 8 square roots of 10 over 10.
Yes.
Am I done?
No, you can simplify the 8/10.
Exactly. Reduce that down to 4/5. So I get 4 square roots of 10 over 5. Good job. Okay. Next situation. We've got the square root of 15 b squared over the square root of 5b cubed. Now, what I want to look at is several different ways of dealing with this problem, and then you choose the one you prefer. Okay. In the end, we need the denominator to be rationalized and the whole fraction to be simplified as much as possible. Okay. So one way of doing this, I could multiply the numerator and the denominator by the square root of 5b cubed. What that would give me in the denominator, it would give me 5b cubed. In the numerator, it would give me the square root of, let's see, 15 times 5, 75b to the 5th. So far, so good?
Yep.
All right. But I can simplify the numerator. I'm going to write that as 25 times 3 times b to the 4th times b. Why all of that? Because I'm pulling out the squares and the 4th powers. Okay. In other words, I'm simplifying the numerator. What's the square root of 25?
5.
What's the square root of b to the 4th?
B squared.
And what's left inside is 3b. Okay. But now what can I do?
The 5b squared and 5b to the third power is reduced down.
Okay, so the 5's reduces down, and the b squared over b cubed would be 1 over b. So I'm left with the square root of 3b all over b. Okay with that?
Yep.
Now let's go back and let's look at it a different way. Let's take this over that. And oh, we've got a fraction with a square root on top and a square root on the bottom. So I could combine them. All right, could do that. And then I could reduce that down. And I'd get what? The square root of what? 3. Oh, I need a fraction there. So let's do this. Three over b, right? Because b squared over b cubed would be 1 over b.
Yes.
Okay. Yeah. And that's equal to the square root of 3 over the square root of b. Don't forget, I need to rationalize the denominator. So now what?
You multiply by the square root of b.
Over the square root of b, which would be the square root of 3b over b. So there's another way of getting the correct answer. You okay with that?
Yep.
All right. I'm even going to look at it this thing the third way. Just what you wanted, huh? Okay. 15b squared, 5b cubed. Is that correct? Yes. Okay. Now, what I'm going to do here, I'm going to simplify the numerator and the denominator before I do anything else. Up on top, I could take out a b and get that. On the bottom, this is the same thing as 5b squared times b inside. So again, I could take out a b and get that. Are you okay with that?
Yes.
All right. Then I could reduce those down. So now, rationalizing the denominator, what would you do?
Multiply by 5b.
Square root of 5b. I know that's what you meant. So now I've got 5b in the denominator and the square root of 75b in the numerator, which is the square root of 25 times 3b over 5b, which is 5 square roots of 3b over 5b, which is the square root of, whoops, square root of 3b over b. So I did this like 3 different ways, and they're all correct. It's up to you to kind of feel like, or to find out which one you feel most comfortable with, okay? And you might try different ones, go, oh, you know, I like this, I like that, but they all work, okay? Sometimes one method's way quicker than another, but I just wanted to kind of open up that can of worms of possibilities. All right. Let's see here. Let's take this one. 11 over the square root of 75 x to the 5th power. All right. We can multiply the numerator and the denominator by the entire denominator, which will immediately rationalize the denominator and then simplify it from there. We could simplify the denominator first and then go from there. What would you like to do? You pick.
We can rationalize the denominator. Or I don't know if Gregory wants to do that.
Okay, so we're just going to start with this.
Yeah.
Okay. So we're there, right?
Yes.
Okay. So things are looking good, except now, can we do anything to the numerator? Yes, we can. Let's see, that's going to be 25 times 3 times x to the 4th times x, all inside. Okay. Do you see why I broke it down into squares, fourth powers, leftovers?
Yes.
Okay. So that's going to be 11 times the square root of 25, which is 5, square root of x to the fourth, which is x squared, and then the square root of 3x over 75 x to the fifth. Okay. Oh, I can take the 5 and the 75 and reduce it to 1 over 15. I can take the x squared over x to the fifth and reduce it to 1 over x cubed. So what have I got? I've got 11 square roots of 3x over 15x cubed. And there we go. All right. Anybody want to explore it a different way? Or are you good?
I'm good with that way.
Okay. All right. Greg, you okay with that?
Yeah, I'm okay with that way.
All righty. Let's see here. How about this one? The square root of 48 x squared over the square root of 8x squared y. All right, how should we go about this? And we want to ultimately rationalize the denominator and simplify the whole mess at the end. Do you want to just immediately rationalize the denominator, or do you see something else that might make life easier?
We can just rationalize it.
Really?
Or you can break down the 48, I guess.
Okay, let me show you what I'm thinking. And both of those suggestions would have worked, but consider this. See what I did there?
Yeah, that was way faster.
Okay, so I'm just saying, be open to these other possibilities. Always rationalizing the denominator. It's going to work, but it might be a lot of extra work. Okay, I set you up for that. I got to admit it. Okay, I was being mean and vicious. So now you just do this, and you're done. Okay. But again, we could have done that other one. It would have worked out. We just would have had to do a lot more simplifying later on instead of at the beginning. All righty. So for the weekend, you've got section 9.4. Monday, we'll have class. Tuesday is advising day. So on Tuesday, there won't be any classes, at least math classes with me. Won't be an office hour. No class meetings on Tuesday. But again, I'll remind you that on Monday, but just letting you know. So have a good weekend. And I'm going to stop the recording.